Okay, this problem is actually a double Pythagorean theorem problem. So the first thing I want to do is I want to go ahead and break this into two triangles. So this little tiny triangle here to the left, you'll see that I copied down below. And from here I'm going to add a different variable, so I'm going to throw a y in there. And now I'm just going to do the Pythagorean theorem. Y squared plus 6 squared, that's my a squared plus b squared, equals, now this is a little bit weird because I have a radical in here, but I'm just going to say 3 times the square root of 5, put in parentheses, and square it. Okay, simplifying things, I get y squared plus 36 equals, now what do I do with this 3 times the square root of 5 squared is I'm going to split it up. I'm going to square both items in here because I can do that because of the property of exponents. So 3 squared and the square root of 5 squared. And simplifying even further, whenever I square root a square or vice versa, those are opposites of each other, just like adding is the opposite of subtraction or multiplying is opposite of division. So basically they cancel each other out. And then my problem becomes a lot easier. So now I have y squared plus 36 equals 3 squared is 9. And I'm left with, if the square root and the square go away, just 5. And now you should get y squared plus 36 equals 45. And now I've got a pretty simple problem here. I'm going to go ahead and just subtract 36 from both sides. And I get y squared equals 9. And then again, the opposite of squaring something is to square root it. So I'll go ahead and square root there. And the square root of 9 is 3. Okay, now I have this part of the problem. I can go ahead and slap a 3 up there. And now I'm going to deal with the second triangle here, this big one right here. And again, I have an A, I have a B, I'm looking for C, which in this scenario happens to be my X. So I'm going to go ahead and break it off here so I have a little section to do my second Pythagorean theorem problem. And I get A squared plus B squared equals C squared. 3 squared is 9, 12 squared is 144, equals X squared. I'm going to simplify a little bit here and get 9 plus 144 is 153 equals X squared. And then I'm going to square root. Now, one thing about this is I can't leave it like this. The program won't like it because I can simplify this radical. And if I were to look through all the perfect squares, and what I mean by perfect squares are the numbers like 1, 4, 9, 16, 25, numbers that if I were to take the square root of them, okay, they would turn out to be a perfect number. And when I do that, I notice that, oops, let me simplify here, 153, excuse me, can be broken up into 9 times 17. So 9 is the perfect square I'm looking for right here because I know what the square root of 9 is and I can simplify that. And then I split up my radical, square root of 9 times the square root of 17 equals X. And I know what the square root of 9 is, it's 3. And so my final answer is 3 times the square root of 17 equals X in simplified form.